Hello everyone, welcome again. This is Mr. Kalab from Complete Chemistry by Kalab. Today we're going to discuss on chemistry from the Ethiopian National Curriculum, which is the new curriculum. We're going to focus on grade 11 chemistry, unit 2, chemical bonding. In this video, we'll focus on introduction to chemical bonding, mainly two topics, the octet rule and types of chemical bonding. But before diving into the concept of chemical bonding, let's try to do this two startup activities. The first question is to define chemical bonding. What is chemical bonding? Chemical bonding is basically the electrostatic force of attraction holding atoms together, holding atoms in a molecule, holding atoms in compounds, and also holding other particles such as ions and molecules together. This is called chemical bonding. Most atoms, we're saying most here, not all atoms, okay? So atoms combine to form compounds. Some atoms, or we can say most atoms except for the noble gases. Okay, most atoms except for the noble gases combine with other elements or other atoms to attain stable outer configuration. So we're saying except noble gases here. What does that mean? Noble gases are exception because noble gases have outer electron configuration of Ns2 and P6, okay? Noble gases, of course, except helium, which has electron configuration of 1s2. All noble gases have outer electron configuration of Ns2 and P6. This is the reason for their stability or unreactivity, okay? This stability or unreactivity of noble gases can be seen from their high ionization energy and their very low electron affinity, okay? So what does that mean when we say noble gases have high ionization energy? This means that it requires a lot of energy for noble gases to lose an electron from their outermost shell, okay? What does that low electron affinity mean? Noble gases have low electron affinity. Due to this, they will have a very low tendency to attract electrons into their outermost shells. Okay, now let's talk about the octet rule. So octet rule is the general rule which governs the fact that for atoms to be stable, they need to have full outer electron configuration, meaning 8 electrons, okay? So atoms, according to the octet rule, atoms lose, gain, or share electrons to have full outer electron shell. To have full outer electron shell, atoms will tend to lose, gain, or share electrons. What does that mean by full outer electron shell? Atoms need to have this configuration, Ns2 and P6 configuration. Basically, they want to look like a noble gas, okay? So that they will be stable or unreactive. So we can look at some examples here. We can consider sodium and chlorine. Sodium having 18 protons, basically 18 electrons as well. We'll have electron configuration of 1s2, 2s2, 2p6, 3s1. We can convert this type of electron configuration into the other one, 2, 8, and 1, okay? So as you can see, sodium has 1 electron in its gas shell. So what does sodium need to do to look like a noble gas? Sodium needs to lose this electron, and then it will have configuration of 1s2, 2s2, 2p6. This is its outer configuration now, as you can see, NS2 and p6. Now it looks like a noble gas, making it more stable, okay? And then let's look at chlorine again. Chlorine having 17 electrons will have configuration of 1s2, 2s2, 2p6, 3s2, 3p5, okay? 2, 4, 10, 12, and 17. Good. Let's convert this into the all the electron configuration that you know from grade 9. This will be 2, 8, and then 7. So for chlorine to become stable, it needs to gain 1 electron to have 8 electrons in its last shell, okay? So it needs to gain 1 electron. Gaining 1 electron will make chlorine have configuration of 2, 8, 8. Now, as you can see, it is looking like a noble gas. This is its outer configuration. This will be 3s2, 3p6, which is full outer electron configuration, making it look like a noble gas. So this is basically the octet rule. Now let's discuss about chemical bonding, okay? So generally, chemical bonding can be classified into two as intramolecular and intermolecular forces, okay? So intramolecular forces are electrostatic attraction forces holding atoms in a compound, atoms in a molecule, okay? But when it comes to intermolecular forces, these are forces holding molecules together, okay? Forces holding molecules together. To make this easy, let's look at an example. Let's look at water molecule. This is one water molecule, and then let's have another water molecule here. This is another water molecule. The fact that oxygen is more electronegative than hydrogen makes it partially negative, and then making the two hydrogens partially positive. Again, the fact that this oxygen is more electronegative, it will be partially negative, okay? So these two water molecules will be attracting each other. The lone pairs of electrons in one of the water molecules will tend to attract the partially positive charge of the other molecule. So these two water molecules will be held together. That is why water is liquid at room temperature, okay? Good. So this is an intermolecular force. Molecular force. This is an intermolecular force. This is a force that exists between two molecules, holding these two molecules together. And then this, and this, they are the same. They are intramolecular forces. So this is basically the difference between intermolecular and intramolecular forces. Intermolecular, we have three types of intermolecular forces. We have London or the dispersion forces. We have dipole-dipole interactions, and then we have hydrogen bonding. We will see this in our next videos. And then for the intramolecular forces, we have three types of bonding: ionic, covalent, and metallic bonding. Now let's say something about these three. Ionic is type of bond which is made between a metal and a non-metal, okay? And covalent bond is a bond formed between two non-metals, non-metal and a non-metal. Metallic bond is made between metal atoms, okay? Between metal atoms. Now let's look at an example for these three different types of bonding. So now let's look at these three. We have potassium chloride, ammonia, and copper. Okay, let's look at these three examples to have a brief understanding about the difference between these three types of bonds. Okay, so now here let's consider one formula unit of copper chloride, and then we'll try to see how these two are bonded. Okay, so in one formula unit of copper chloride, we have one copper ion and one chloride ion. So the electrostatic attraction between these two opposite charges will give us our copper chloride. And then when we try to see at ammonia, we have This is the structure of ammonia. So this bond stands for 2 electrons, 1 electron from hydrogen, 1 electron from nitrogen. Again, so covalent bonding, as you can see, is made by sharing of electrons between 2 nonmetals, okay? And unlike ionic bonding is made by transfer of electrons, complete transfer of electrons. That is why we will have a positive and negative charge, okay? So potassium will lose 1 electron and then will attain a +1 charge, and chlorine will gain 1 electron and will attain a -1 charge. So the electrostatic attraction between these two oppositely charged ions will keep potassium chloride as a compound together. Now let's look at metallic bonding. So metallic bonding is somehow different from these two types of bonds. This is due to the fact that the valence electrons in metals are not tightly held to their corresponding nuclei, okay? So what does this mean? For copper, we have 2 electrons in the valence shell, okay? 2 electrons in the valence shell. So these 2 electrons from every copper atom will not be strongly attracted to their corresponding nuclei. This means that they will make sea of electrons. Let's consider this as a copper plate or a copper metal, and then the electrons will make, the valence electrons will make sea of electrons like this. So that the positively charged ions, copper, after losing 2 electrons, it will be copper 2 plus, so that these 2 plus ions will be represented by a positive charge here, okay? So this is the metallic bonding representation for copper solid, where this minus side represents the delocalized electrons, and these positive signs indicate copper 2 plus ions or the cations, okay? So basically, ionic bonding is an electrostatic force of attraction between a positive and negatively charged ions, and covalent bonding is an electrostatic force of attraction between the shared pair of electrons and the nuclei of the 2 bonded atoms, and then it is formed by sharing of electrons, unlike ionic bond. Ionic bonds are formed by transfer of electrons. And then when it comes to metallic bond, have in your mind that the valence electrons of metals are not tightly held by the nucleus, meaning they are free to move throughout the structure. If this is a piece of iron metal, and then an atom of iron in here can have its electrons throughout the structure, okay? What does this mean? They will make sea of electrons. And the positively charged ions now, after losing the electrons, will come and be embedded in between these delocalized electrons. So there is an electrostatic force of attraction between the metal ions and the delocalized electrons, what we call metallic bonding. Thank you. This is part 1 for chemical bonding. See you guys in part 2.